Okay, today is going to be a walkthrough of the Road to Las Vegas Battle 1, which was Doggie Daycare. So the premise of the case is basically you have this map of a doggy daycare centre. The brown areas are feeding areas, the blue are bathing areas, and you are basically given a starting cell, a series of directions, which look like these arrows here. So this first arrow would be moving 2 times diagonally upwards and to the right. And the case is going to basically ask where the dog ends up, with special things happening if they land on a feed area or a bath area. So bath, they will basically skip the next 2 turns, and if they feed, then their movement speed will double for the next 3 turns. So that's the case. There's a couple of lambdas which I have for this one. Basically, I only ever make these lambdas when something comes up twice. So you'll see as I do these walkthroughs of each round of the competition that these will be reused. So the first one is this most of lambda here in the middle. So I'll just show you what that does. It basically is going to take any array and tell me what the most common things are in that array. So I can see there are 11 greens, 6 blues, and so on. It's also quite interesting that I can use it on a single cell, and it will spit out every letter or character in that cell and how many there are. So that's really useful that I can use it on 2 things there. I also have arrows, which is super useful because it just spits out the 8 directional arrows, the row movement and the column movement for each one. I previously used to type this out in each case, but since I had to do it so many times, I just made a lambda that does it correct every time. Next lambda is this case questions one. I use this a lot of the time. So if I come to a file and I type case questions, it's going to give me like all of the levels and specified details for each question. So then I can find like most common things and whatnot, and it eliminates all the examples. So you will see me use that in this one. And then the most interesting one is a move on map lambda. So given an arrow like this, I'll just zoom in a bit so you can see that, and a starting cell, let's take G57, just a random cell there. If I say move on map, I start at this cell and I move in this direction, it's going to tell me what cell I go to. So that's going to go to G58. I also have an optional argument in this one to add a multiple. So if I put a multiple of 5, then we're going to move down 5 times from G57. All that lambda is doing is looking into this arrows table, taking the row or column number and multiplying it by that multiple. Finally, I have 2 optional arguments for this, which is a min row, max row, and same for columns, which defines the bounds of a map. So that's really useful in this case because we do have bounds on our map. Some of the questions later on say that the dogs cannot move out of these bounds of the map. So that's going to be 2 to 51 in this case on the rows and the columns. With all that setup explained, let's close this and go through the case. So first of all, we want to know how many cells are in the feeding and bathing areas combined. So for this one, I'm going to call these W for water, and then I want to call all the other ones feed. So let's just do Control H, take the format and change those to feed, and that will do that. And then I can find out what I've landed on later. So I've labeled them distinctly, and the count here is 142, which I can see in the bottom corner when I highlight everything. So 142. The next question is, what's the most common direction that appears, excluding those without an associated movement amount? So that's excluding these bits here. So we want anything with a length of 2, basically. So this is where one of my lambdas comes in helpful. So I will type case questions, and then, so that's everything in the case. And I'll probably copy paste it as values so that I can remove those arrows here because they don't have an associated movement amount. And then we can col of everything. We can then just take the rightmost character of that, and then we can do our most of lambda here. So most of this, and then we see everything. We can see this arrow is the most common with 559. So that should be the answer there, 559. Then we want to know what the row and column numbers are for all of the starting cells and add them up. So again, I can use this sheet. So equals row of indirect of all of these starting positions, and then we can do the same for the column, and then we can just add those up here. The sum is 4170. And then we'll leave these till later because they're related to questions. So the first question is asking us to add up all of the number only parts here. So that's just going to be the left of all of these. We have to times it by 1 to convert it from text to a number and sum those all up. So that one's nice and easy. Next, we want to know how many times the specified arrow appears in this list. So we want to filter that list for where the arrow is correct. So we will filter this for where the right of that equals our specified arrow. So that's going to give us an array of all of them, and we want to count how many columns there are to that array. And that should give us our answer. Okay. Now the next one is basically saying diagonal movement is worth 2 and anything else is worth 1. So what is the total sum of all the movements? So this is where we're going to use our arrows lambda here to just spit those out, and if anything diagonal we want to give it a 2, and for anything else we want a 1. So let's do that. Then we want to do x lookup the right side of all of these, so we just take out all the arrows. We're going to look for them in here, and we're going to return the number. That's basically going to give us an array that is just the number that each arrow is worth. We then want to multiply that by the left side of this, and then we want to sum it all together. And there we go. The next thing is asking how far a dog has travelled over these turns horizontally and vertically in absolute terms. So let's call it row and column. So this is going to be exactly the same as the last formula. So I'm just going to put that in here for the row. However, we want to change our input to those of the question. So let's do that. And then we're also currently looking up this bit here. We want to look up the row movement. So that gives us our row movement in total. Let's do the same thing and pull this over to the columns. So now we're looking at the column movement, and that's our answer. So what we want to do is sum these up, but we want to sum the absolute values of them. So we'll do absolute there. And that's our answer. So let's drag this down all the way. And that should be it. Okay, now we have a starting cell and these movements. So let's actually do this in a new solver sheet. So we'll say example 5. We'll look up that in here. And we want G out to L. Okay, and we want to go to call of this array. And we basically want to know where the dogs end up after all these movements. So this one's very easy once you have the lambda that I had. So first of all, let's split this down. So equals, let's do the multiple first, the left of this, and then let's do the right of this. And we can do, let's put our starting cell above, and then we can do move on map. We are moving from this cell with this arrow and this multiple. That's going to give us our ending cell here. And then we can just data table that over here. And there we go. So nice and easy once you have that lambda. If you didn't have that lambda, what I would do is, again, look up into my arrows table, spit out the row number, spit out the column number, times them by this, and add them onto the starting address. So it's the same thing, just I've put it into one formula, essentially. With that done, we can now do the next bonus, which is asking if a dog starts in AAA 1000 and follows all the movement directions in games 121 to 160. So we can actually pull those from here because we have this sheet that gives us all the information from the questions. So 121 to 160 is here. So let's just copy that into a new tab. And then I'm gonna to-call it. There we go. And then I want to filter that just to get rid of the zeros. just to clean it up a bit. So I have all of my input directions. Let's put that back into my solver tab here. Let's delete this out and go from there. Just got to grab it again. Then drag that all the way down. Our starting cell was AAA 1000, and let's see where we end up. So AHD 909. All right, next up we have the same thing, the starting cell and a load of directions, but we want to sum the turn numbers in which a dog eats food. So let's go back to our sheet here, change it to example 6, and then we want to delete this out, and we want to do same as what we did before, 2col of all of this. Our starting cell is going to be here, and this actually goes out to column AA, so let's do AA. Okay, and then, oh, I should have actually not deleted those other bits out, but that doesn't matter, let's just put them back in. Left of that, right of that. And then let's do move on map. From this cell with this direction, this multiple, then we can drag those down. And then for our answer, we want to know what turns they eat food. So let's find out what's in the cell with indirect. I'm just going to call this M for map. So equals indirect of M and our cell. Then we want a turn number. So let's do sequence of count A of this array minus 1. And that's going to give us a sequence, so 20 turns here. Then we can do sum ifs. We're going to sum those up. Let's actually do it as an array where this is a feeding area. And let's put our correct questions in. And there's our answers. There's actually one that's wrong here, and that's because one of the dogs, this one, does go out of the bounds of the map. It says in the question that they don't go out of the bounds, but they actually do. So we can add the bounds in now into our formula, which we know is 2 and 51. 2 and 51 for the rows, 2 and 51 for the columns. Oh, is it 2 and 52 or 2 and 51? I think it's 51. Yeah, 51. And that will fix it. So the answer is actually 1. I think that's a mistake in the case because those bounds shouldn't come into the last question, but we'll continue on anyway. Now we're going to skip the next 2 turns whenever they take a bath. So first of all, we want to find out whether they have a bath. So let's say if this is a W, then 1, otherwise 0. So that's 1 for taking a bath, 0 for not taking a bath. Now the trick with this one is once they take a bath, they never take one again. So we need to check if anything above this cell has a 1 in it. So let's do another if. So if the sum of everything above, let's do a colon, so it drags down with the formula. So if that sum is above 0, then do 0, otherwise do our original formula. So now that second one will turn to a 0 there because they've already taken a bath. So now we want to put the multiple to 0 if any of the last 2 turns were a bath. So let's say if or this equals 1 or this equals 1, then we'll do 0, otherwise we'll do our original left side. So now what you'll see is when they land on a bath cell, the next 2 turns multiple is 0 and we no longer move in our cell. So that should give us the answer. So let's just put our question numbers into the data table. And then again, we're summing up the turns that the dogs eat food on. Okay, and then the final hardest question, this one actually goes out to cell DC. So let's do that. DC, and all we're going to add is the food now. So if any of the last 3 turns were food, we're going to double the movement distance. So we'll keep the bath as 0, but we will say if so the last 3 turns, if any of those are an F, I missed an equal sign there. So if any of those say F, then we are going to do 2 times the movement direction. Otherwise, we will just do, hang on, this is wrong. So if any of those, then we'll do 2 times the movement direction. Otherwise, we will do 1 times the movement direction. There we go. So now you'll see where there's an F here. These numbers here are doubled up for 3 turns. So let's drag all of this down. Oh, and we also need to add the bounds of the map. We already have that in. So what's wrong? I need to change this to example 8. That's what's wrong. There we go. So that should be, so then let's add our question numbers in. And we want all of these, and that should be our answers there. Cool, and finally the last bonus, which is quite tricky, which is saying, in level 8, the one we just did, as the dogs move through the center, how many times are they in the same cell together? So what we want to know is, for every turn number, what cell are the dogs on? So that is just these cells down here. So if I go equals transpose this, then this is going to give me turn number 1, the dog is there, turn number 2, the dog is there, and so on and so on. So if I do that for every dog with the data table, now we know every cell that every dog is on each turn. So, you know, question 141, the dog goes to these cells, and then the next question it goes to these cells. So we want to know how often this thing is the same, because it means 2 dogs are on the same cell. So what we want to do is count the unique instances of it. So first of all, let's type unique of these. And then we want to know how many of those there are. So let's do rows. And we know there are 20 questions here. So if we want to do 20, the number of questions, minus that, and we'll know how many times dogs are on the same cells together. So let's pull that across. And if you sum it up, we have 16, which is our answer. So that's basically, you'll be able to see in this one, so you'll be able to see a duplicate there. So on that turn number, the 2 dogs there were in the same cell. So that is it. I will try to continue uploading all the cases this year, and then hopefully some other content on Excel and accounting and whatever else. But yeah, hopefully that was useful. Subscribe if it was. That is my solution.